This semester, we had the privilege of working with a large Midwest diesel engine manufacturer. They manufacture many specialized engines, and all of the engines share some common parts, including the valve guides. Valve guides are small, metal cylinders that properly locate an engine's inlet and exhaust valve. 24 valve guides are pressed into the cylinder head of each 9-liter engine in an automated process. The force of each insertion is automatically measured and must fall within the control limits set by the company. They aim to produce around 140 engines per day, resulting in over 3,000 valve guides being pressed each workday. The company currently uses cast steel guides, but is switching to powdered metal guides for potential reduction in material cost. Valve guide insertion forces occasionally fall outside the control limits, resulting in costly rework. The current process capability of the cast steel guides in production is 1.088 for the number 1, number 2, and number 4 guides, and 0.825 for the number 3 guides. The number 3 valve guide is pressed into a different sized hole and has different control limits from the other guides. The primary goal of the project was to investigate ways to increase the process capability to at least 1.5. The secondary goal of the project was to determine and set viable control limits for the new powdered metal guides.
In order to understand the current interference fits present between valve guides and bores, all of the bore diameters and all of the valve guide outer diameters were measured using a coordinate measuring machine, or CMM. Two programs were utilized, one to measure the cylinder head bore diameters and another to measure the valve guide outer diameters. A gauge R&R study was completed for the measurements taken on the CMM to verify its precision, and the results of the gauge R&R study can be seen here. It was hypothesized that the washing process each cylinder head undergoes before valve guide insertion may have resulted in a significant change to bore diameter due to thermal expansion. To measure the effects of thermal expansion, the temperature of one cylinder head was raised to 100 degrees Fahrenheit, the measured average temperature of cylinder heads exiting the washing process provided by the company. A statistical analysis of the measurements then showed that this temperature change did not have a significant effect on bore diameter. To determine what effect interference fit had on insertion force, valve guides were inserted into bores in order from smallest interference to largest interference. From the insertion force data shown, it is likely that as the powdered metal valve guides are introduced, the standard deviation of the insertion forces will be reduced.
The cost savings from switching to powdered metal guides is approximately $600,000 per year. Our project is not directly responsible for making this switch feasible, but the preventative measures of increasing the process capability and the necessity for setting new control limits for the material makes our project a part of the process. Although it is difficult to value quality and preventative measures, the group concluded our project was instrumental in 5% of the switchover to powdered metal valve guides, resulting in savings of $30,000 annually. In total, this project saved $30,000 per year and had an initial project savings of $18,600, yielding an approximate $84,600 3-year net present value using a 15% adjustment rate.